Hi everyone. Just to let you know before we start, this session is being recorded. You should know that from the email, but it's always good to highlight that just in case. My name is Donna Smith from the Open University, and I'm the co-chair of the PSA Teaching and Learning Network. Welcome to the fourth PSA webinar series. We're delighted to be back with another webinar series. Thank you to all the previous speakers and participants for helping to make those series so successful. Again, just for any kind of people who just come in, we are recording, and I'd be really grateful if you could mute your microphones until the question and answer session. Today's session is called Flipping the COVID-19 Classroom, led by Adrian, Millican and Thomas Robinson from Durham University. The session will cover adapting face-to-face to online teaching, focusing on level 1 statistics teaching, looking at the changes needed to mow the delivery and the introduction of flipped lab sessions, as well as the challenges and benefits of this approach to teaching stats. This is actually the first of 2 webinars focusing on quant stuff, a strand of the Teaching and Learning Network we hope to build on in the future. We're due to finish in about an hour's time, and there will be time for questions at the end. I'll be moderating the chat box, so do post your questions there. And again, please note the session is recorded and make sure you're muted for now. So without further ado, please welcome Adrian and Thomas.
Thanks very much. Today we're going to talk about some of our experiences over the past year through our teaching of undergraduate level 1 statistics. So briefly, just to start off a little bit about us, I'm Adrian Millican, an assistant professor in comparative politics at Durham University, been here since 2017, with a teaching focus that really covers statistics and methods primarily, with substantive areas related to comparative politics and British politics. Tom, do you want to introduce yourself?
Yeah, sure. Hi, everyone. I'm Tom. I'm an assistant professor in quantitative comparative politics, and I started at Durham this year, a bit of a baptism of fire. But like Adrian, I predominantly teach in statistics and methods, bits of research design and methodology. My own work is broadly comparative too.
So what do we sort of go through today? Well, ultimately, we focus on the problem that was COVID-19 and the transitions in learning that needed to happen in rather sort of hurried fashion as it sort of started at the tail end of March last year, and the sort of thought processes that we went through as we tried to design a course for blended or perhaps even online only learning throughout the summer. So we're going to start off with a bit of an overview of the course as it was. So what we were doing, what types of practice we employed before COVID-19, the changes that we made as we started to approach online learning, how we rethought the module, what aims we wanted to achieve, what lessons we have learned over the past year, and the directions that we think we still need to go in going forward. So what do we offer in this presentation? Well, I guess the main point is making the most of an opportunity. So while COVID-19 represented a number of really, really big challenges, it also gave the opportunity to think about the practice that we employed and renewing the teaching methods and style and approach we had in teaching statistics. So really we're looking at a sort of wholesale change and what benefits this has had. Alongside this, we really offer a bit of a defense of online teaching going forward. So I know the media and the sort of response from students in general has been that online teaching is often not what they really want, or perhaps not often as effective as it could be. We want to offer a bit of a defense of that and sort of talk about the major benefits that we've seen this year as we've gone from teaching in the classroom previously to teaching statistics in labs online. And also a bit of a defense of using R outside of the Q-step centers and the practical benefits that this form of software can have, particularly when we move to online only environments. And then finally, just sort of ending with an evaluation and directions for the future. So to start off with, just a little bit of background, obviously the COVID-19 pandemic itself. So as we're all aware, global pandemic really led to some rather rapid changes in a lot of universities. They tried to adapt to a really fast changing situation. For many universities, this sort of started in March. Most of the teaching that we had done in Durham sort of had finished at this point last year. So there was a rather sort of limited practical experience of the challenges that this would cause at that time of year. So we did have a perhaps longer period than most to really get to grips and consider what needed to be done. So obviously COVID-19 itself created a number of challenges. So thinking a little bit about how we were going to engage students online, how do we keep classes interactive? How do we make sure student engagement remains high? How do we ensure that learning outcomes are achieved? I think this is particularly problematic for classes that tend to be more practical. So classes that are sort of lab-based, such as the ones that we discussed today, where very close contact and engagement with students is the norm. So, you know, the benefits of being able to walk up to a student sat at a computer and physically take control of the computer and help them work through code and find options suddenly disappears within this online environment. And thinking through how we can replace these types of elements that you know make learning statistics easier for the students is sort of a key thing to think very carefully about. But on the flip side, it also offered a great opportunity, you know, an opportunity to take a step back, think about our broad teaching practices and thinking about how we could really improve and take advantages of technological innovations and the new opportunities that are available. So in general, what we're talking about here in a lot of ways is an approach that is not particularly groundbreaking as such, but we want to offer some thoughts on hopefully ways that we've sort of worked with this year that have proven really successful in terms of how we can teach statistics. So really we address a sort of specific question. How can we transition labs to take advantage of these new modes of learning? So a little bit of background to the module. So the module itself is Researching Politics and International Relations, and it's relatively new within the School of Government and is not something that's been taught for a long time period within Durham University. So its module is relatively large. It's approximately 150 students, contains all single honours politics and international relations students, and also picks up combined honours students from a number of different disciplines along the way. And its main aim is to give students a really broad overview of how we research in politics and IR. So very basic skills related to what questions are, how do we ask them, what the role of theory is in research, how we conduct empirical political science research, and then sort of two more specific sections on methods. So a section on qualitative methods and a section on quantitative methods. So the main aim of today is to sort of talk a little bit about the quantitative methods element. So prior to COVID-19, the structure of the teaching in the module followed a relatively sort of straightforward format that is quite common in methods classes. So there were 8 hours of lectures related to the quantitative component of the module, with 5 hours of labs and 4 hours of seminars. And the approach again followed what would, I guess, be described as a fairly traditional approach to teaching statistics. One element of this was the teaching of the sort of underlying calculations that make up the statistics through applied walkthroughs. And while I realize, you know, this is something contentious in the literature, it's not a sort of core part of the assessment that we have, but we did sort of feel it was important to expose students to it, because some students just learn well by being able to see how the sort of statistics they're working with are broken down. We've always aimed to use diverse data relevant to politics and IR to ensure that students understand how broadly they can apply quantitative methods, and also an emphasis on support for students and regular checks on learning. So attached to the lectures and the labs, there were self-marks, homeworks that were reviewed either in the seminar series or within the labs themselves. So lots of opportunities for students to sort of understand how they're doing and figure out where they are in their own learning environment. We also tended to focus reasonably heavy on data management. transferable skills beyond study of politics being particularly important, and evidence sort of demonstrated that pre-edited lab materials that reduced data sets down very, very small and had already sort of dealt with data management, coding, getting rid of missing values, limits the sort of ability to apply these skills in the future. So we always try to, provide some sort of data management angle to this course as well. The running of the labs prior to COVID-19 focused on the SPSS software package. A number of reasons for this. Primarily, it was a software package that was available on all university computers through a site license, and students could also have free copies to download for their own personal machine, which meant there were lots and lots of opportunities for them to practice outside of the traditional lab environment. The labs themselves, so 5 one-hour labs, were split into 2 sections. So a first half being teacher-led, running through examples, illustrations, and engagement with the software to help them learn the sort of basics, followed by practical applications of the skills that were learned in the lecture, so demonstration of the different statistical techniques we wished to engage them with, and demonstrations of some of the sort of background theoretical ideas through examples as well, with the second half of the labs being student focused, so working through tasks, challenges, and focuses on using the software and a real strong focus on the interpretation of statistics, so trying to build more on practical application. However, it would sort of be fair to say that a number of these things didn't work quite as well as we might have liked, and even without COVID-19, these might have been things that would require, sort of further work and revision. So particular problems of this module were students just not doing the preparation. So despite having all of the resources and the homeworks and the exercises and resources, simply not coming along prepared, ready to sort of focus on application. So in the end, they ended up trying to cover learning statistics and the software within 1 hour. And accordingly, this kind of meant that oftentimes illustrations, examples might run over a little bit, allowing sort of limited time for knowledge to actually sink in. So students sort of were leaving the classroom before they thought of the questions which they really wanted to know the answers to. So obviously, as I said, this module, was subject to sort of new thoughts and the potential for new approaches, but this was really sort of pushed forward quite dramatically by the sort of COVID-19 issue. And this required a number of considerations for the online pivot. Some of these sort of specific to the module, some of these broader decisions taken in order to ensure continuity across our undergraduate curriculum at Durham. All of the sort of considerations for the online pivot, both at a module level and in a departmental level, were really geared towards thinking about sort of accessibility and EDI. So a key consideration that sort of governed all of the types of issues that we faced when thinking about how to pivot to online and blended learning really focused on EDI. So making sure that regardless of the student's circumstances, they would have the ability and the resources to actually complete the course effectively, meet the learning outcomes, and would not be disadvantaged by their background. And these kinds of issues were central to all of our thinking regarding, technological issues in terms of what technology solutions were most appropriate for the students, thinking about the lessons that we did learn at the tail end of the academic year 2019-20, in particular in relation to the sort of assessment processes. So thinking carefully about the software that we use for the statistics element, the software that we use in order to engage for the actual classes, focusing sort of carefully on the communicative issues. So how can we best structure our classes to increase engagement in what would always be challenging sort of environment for students to navigate at the beginning of a degree program, coming in with no real background of who's who, or having those sort of strong networks of friends that they might sort of really rely upon as they try to navigate their way around university. How can we best distribute the hours to support student learning is another key question that we really wanted to focus on. And also just a sort of more reflective question on the content that we teach and the way we approach it in terms of what do they actually need to know? What are the sort of key things that we think they need to understand in order to really effectively take these skills forward and apply them to other modules, their dissertations, and more importantly, in terms of employability and how they can sort of get on and achieve once they leave university, having completed their education. So again, communication issues was particularly important in relation to these sort of EDI type issues, particularly if we think about students who may not have the best types of connections. So a particular problem amongst first generation scholars and potentially international students. So we felt it was really important to think very carefully about the approach we took and to make sure that whatever their situation, they would be able to achieve and engage. And then of course, resource issues. So how can we best mitigate and make sure that students have access to all of the materials they need to support their learning, in an area which we all understand statistics can invoke some degree of anxiety. So making sure that they have those resources they need in order to feel like they can succeed. So in terms of mitigating COVID-19, there are a number of areas that we really focused on. So in terms of contact time, making sure that we increase the small group contact time that students have. This is not just sort of an important factor for us this year in terms of making statistics successful, but also in enabling students to, feel like they're being somewhat socialized in and learning who people are and potentially making links during a really unusual time. And also increasing the amount of practical time spent learning the software and applying statistical knowledge. So again, for us, a big sort of thinking point here was, how much do we need the lectures? What's the role of the lectures in teaching statistics in the manner that they were? And are there any ways that we could potentially use this time in a better way to enhance the education that they're getting? Another key factor, again, in terms of accessibility was software. So making sure that they all had access to the software that we were going to use, that it would be widely compatible and preferably open source, to make sure there are very limited barriers and hopefully will be very few students that may have difficulties in regard to this. And again, increasing the focus on the practical nature of statistics. So thinking carefully about the content. So potentially still including the mathematics, but making sure that the main focus and the main sort of time spent in interactive sessions is focused solely on interpretations. We also had to think carefully about the expectations about what we could achieve, making sure we focus our efforts on the things that students most needed. So the application of statistical knowledge and data management were highlighted as being by far the most important elements that we thought students needed to get to grips with when learning statistics. So then there were the sort of digital labs elements. So making sure that we thought carefully about the materials that they required, making sure that any videos were required in advance. We chose to use Encore, part of Panopto, purely because we sort of had agreements within the department to limit the number of ways that we were engaging with students to make sure they understood. Similarly, live classes through Blackboard Collaborate, much for the same reason. It was felt, even though there might be other options that were suitable, having an alignment within the department that we were all using the same types of software would make it easier for students to navigate, make sure they got to their classes and make sure they understood how to use the software. Then we had considerations relating to resources. Firstly, in terms of staff hours and availability, so any shift away from the sort of traditional lecture may have implications in terms of the resources of staff required to actually teach these classes, limits on the requirements of purchases, so making sure students were prepared, and any e-prints that we needed or chapters, making sure they were available where necessary. Though we did really try to work hard to limit the number of these that we needed, as well as thinking very carefully about suitable module-specific resources. Then through delivery, again, aiming to increase the student-led aspect of teaching, and really importantly, increasing the active learning component of the module, and primarily this was considered through flipped classrooms, which is where I'm going to pass over to Tom.
Great, thanks, Adrian. I might just be able to request control. So now, hey, so I should now be able to, fantastic. Great, so yes, flipped classrooms. So this is kind of clearly something that we had to do in response to COVID, but this is also something that was being trialed in other universities around the world before, and has some kind of more kind of pedagogical support in the literature. So why did we want to flip, and what exactly does flipping entail? Well, basically it means shifting lots of the kind of lecture material, one-way delivery of information, away from the actual time we spend in the virtual room with the students themselves. So in fact, we can use that time just to focus on in-class activities and interactive ways of learning that are going to allow us to kind of apply the core content in a very applied, very hands-on manner. And in general, what this is going to allow us to do is increase the amount of active learning that's going on in our classrooms. And they're the kind of higher learning skills that we really want our students to take away. What I don't want a student to be able to do is just to be able to recite the central limit theorem. I want the student to know when it's appropriate to take a mean and to work out the variance surrounding that mean in actual real life situations where that's going to be useful to them, both in terms of their degrees and when they leave the university, when they graduate. And also, we thought that flipped classrooms were going to work really well because we're now getting into this kind of Gen Z territory where YouTube has just been a feature of life for these students since the get-go. And so they're very used to these kind of shorter, sharper, tutorial type videos that allow them to learn things quickly just via video. So we didn't think that this was going to be an alien type of experience for these students, which perhaps if we'd done this 5 or 10 years ago, it might have been. What this also means is that in that kind of interactive, active learning session, we can actually continually check on the learning of our students rather than just trying to kind of spill the beans on the central limit theorem. What we can instead do is check whether they understand it, like whether they've got the core point of why these sorts of statistical theorems really matter. And in turn, to provide frequent feedback. So in every session, students had the opportunity to contribute to the class and work out whether the code that they'd worked on previously had actually kind of sunk in, whether they got it right, whether they understood the sorts of coding procedures that kind of we asked them to look at in these workbooks. And it also, allowed students time to kind of think about what's challenging them. So Adrian said already that in the kind of 1 hour session where you're trying to teach the statistics and get them to code it and then interpret it, you just don't really leave any time for the students to actually internalize these lessons. By kind of shifting the actual learning content about statistics into these videos and asking students to look at it in the week before their lab sessions, they have the time to kind of internalize some of these concepts and lessons. And therefore, when they get to the lab, they've already had some time just to kind of digest it in their minds and formulate clearer questions that we can therefore kind of target in the actual lab sessions as a group. Sorry, Adrian, would you mind shifting along one? It's not responding very well to me. Great. So I said that there's some kind of support for this in the literature and kind of in practice. So what do I mean by that? Well, actually, we found that kind of in recent years, there's been strong evidence that flipped classrooms where you push the actual learning to videos that occur prior to the sessions, that actually has or is beneficial towards student attainment. And in fact, this is true not just in general, but for political science and international relations, where authors have found that flipped classrooms lead to an increased satisfaction in class. Students feel they're getting more for the time they spend in these labs. And also it makes them feel like they're being challenged, which isn't particularly hard for statistics because it's likely very new to students anyway, but it's good that they feel like this is actually kind of really positive material that's pushing them to learn new things. And if we think about why this might happen, why is it that we can kind of boost attainment and satisfaction when actually we're shifting kind of the teaching to videos? Well, it seems like there are kind of two components to learning statistics. The first is actually learning the software, and that's true whether you're using SPSS or R or Stata or any other wacky program that you've decided to implement, that is just really challenging, right? There's always going to be that first 30 minutes when you're learning a new command or a new statistic that it's just going to be really frustrating to get right. And the more time you spend trying to teach that bit and overcome the difficulties in the lab, the less time you have to actually think about the higher level analytic skills that you get out of actually applying the method in real life situations. And actually, there's only so much that we can do in terms of learning the actual software itself. You do have to generate errors in order to learn how to fix them yourself, to recognize that this specific message or this specific error means that, oh, I've missed a comma here, or I'm missing some quotation marks there, or I haven't read in my data correctly. And that's kind of stuff that when you let students have slightly longer to do, they can kind of pick up on their own. And that means that when you come to the lab and students already know that, oh, I just need to check whether that's a capital letter or everything's included in quotation marks correctly, because they've already done that, when they come to the lab, we can start talking about things like, well, what exactly does p less than 0.05 mean? Or what exactly are we doing when we run a correlation test? Can we interpret this result causally, for example? So in short, what we're going to do is we're just going to shift all of that lower order learning, the how do I open up RStudio, how do I read in my data, how do I actually generate the t-test output, to videos, so that students come to these labs hopefully prepared to discuss and learn how to interpret these particular statistical procedures that we want them to take away by the end of the module. Can we... Sorry, Adrian, I know this is a pain. Great, so how did we actually do this? So how does this differ from the pre-COVID module? Well, as Adrian said, we wanted to make sure that the kind of software was easy and accessible for everyone. So the easiest way to do that is just to provide an open source piece of software that has kind of the maximal level of support across different hardware. And I'll come back to kind of issues with hardware in a few slides' time. But basically, SPSS works great. It's a really nice introduction to kind of running statistics on data, but it has a few kind of flaws. For one, it doesn't work on all systems, so it doesn't like Linux or Linux-based systems particularly well. And especially since we weren't going to be able to troubleshoot issues in the class, and SPSS is one of those really annoying programs that has lots of dialog boxes that pop up, we just felt it was easier to transition away from this type of software, in particular because it's not free. So even if Durham or your institution provides SPSS for the time that the students are members of the university, what happens when they transition to the workplace, and then in fact it turns out that their small or medium enterprise doesn't have the funds to afford a site license for SPSS? Ensuring that students can kind of take away these skills was kind of a key kind of impetus for how we revised this course for the post-COVID world. And actually, despite the fact that we all know that R has this really high learning curve in the kind of early stages, primarily because it's more of a programming language than it is a drag and drop, click on the screen type SPSS experience. Actually, once you kind of get over that very steep initial learning curve, it levels out pretty quickly. And there is some kind of teaching evidence to show that students don't find R any more intimidating than SPSS these days, in part because I think lots of these students are now coming from primary or secondary school experiences where some form of basic programming or coding is part of the curriculum or part of what they learn. And therefore, some of the things that would have been very alien to us 20 years ago are now much less alien to these students today. And again, the nice thing about R is that it is so hands-on, and it kind of allows us to build in lots of kind of development opportunities, data science type concepts that are going to be kind of really important to employers once they leave the university. So in terms of contact time, how did we change things? Well, we doubled the lab time and we halved the number of lectures. So what that meant was that each student turned up to 5 sessions, each of 2 hours long, rather than the original 1 hour. And in addition to that, they had pre-recorded material to go over ahead of time. So that's where we introduced how you did things in R. So this is the video on how to run a t-test, for example. The students watched that, then came to the lab, and we worked out how to kind of interpret that t-test and what it actually means in kind of applied terms. What this meant in general was that whereas in 2019-20, we had about 5 hours of guidance in actually implementing and running statistics, this year, despite the challenges that COVID brought, we were able to up that all the way up to about 20 hours of guidance in terms of the kind of offline videos that they were able to watch, and also the synchronous component with us in these virtual labs. In terms of the actual flipped nature of this, we had handbooks with solutions that students walked through in their own time, following the kind of offline videos that we produced. And then what we do in the lab is walk through the handbooks again, making sure that students understand, using things like polls to check that we kind of had good average number of students getting the right results. And then kind of as students asked questions or as students raised important points about how we interpret these things, we were able to add even more detail, time that we wouldn't have had in pre-COVID world, where essentially we're just kind of trying to get through the core material in the hour that we had. So this was really nice. It's kind of a very kind of, oh, I hate this word, but synergistic type of learning experience where, you know, students could facilitate our own teaching by saying, well, I didn't quite get this bit, or I thought this meant this. Can you go over this more? And it just enabled a much more kind of fluent rapport between teacher and learner. Sorry, Adrian, would you mind? Oh, I might have done it. There we go. Okay, cool. So how did the labs actually work in terms of resources? Well, one very nice thing that we had at Durham was to always have two staff members in every lab. In fact, that was me and Adrian. And what that meant was that one of us could lead the session, whilst the other did something, played a support role essentially by operating what we called a breakout room. So one of the nice things with these kind of newfangled Skype-esque software video solutions platforms, there you go, is that you can have these breakout rooms, right? And for a statistics lab, what was really nice was that when a student had a specific technical problem, they could just ask in the chat to go into that breakout room. And then the person not leading the session could kind of break away from the main group and just help them fix that problem by sharing your screen or just discussing the issue. That meant that we weren't interrupting the class as a whole to wait for that student to catch up. For example, we could do it at the same time. We used Blackboard Ultra, which was the kind of university solution to host these sessions, and all our pre-lab videos went onto Panopto via Encore. I can't remember which way those two things go around. In terms of the pre-lab work, it was just 5 one-hour videos and a set of handbooks that we worked out should take about an hour for them to complete once they followed the video. I've already said that this was kind of 5 times 2 hour live sessions, and it was mainly focused on why things were working, not how do I run a t-test, but why does the t-test give me this result, and why is that important for the kind of practical, political or international relations problems that we were looking at in each of our sessions. And we really did try and kind of cover a whole kind of gamut of different data. So we did everything from kind of British electoral studies stuff through to country level analysis, international organizations, civil war and conflict, all these different things, trying to get them kind of exposed to lots of different areas of our admittedly broad discipline. And then after the labs, we had some kind of additional homework exercises that the keen beans could kind of do in their own time with solutions, and also more generally just getting students to think through, okay, I know how to use R now, I get what a t-test is and when I would use it, why is this relevant to the specific things that I'm interested in. And then on top of all of that, the really helpful thing that we did was just to put together some very short kind of additional video resources that kind of smoothed the way at the various kind of different stages of the module. So at the beginning of term 2, when students were first exposed to statistics, we had some video resources on how to install R and RStudio on your system. So we did separate ones for Windows, Mac OS and Linux because they're slightly different processes, but we walked them through screen sharing from what's the web address through to how do I download it, through to how do I open it, and how do I make sure that everything's working. And that included installing the packages that we were going to use throughout the rest of the term, things like tidyverse. We also had some more kind of general tutorial videos on how to recode variables. So we focused on looking at both categorical data as well as numeric data, how to create things like indexes. So if we want to create one variable that kind of captures 5 dimensions or 5 separate questions in a survey, how would we do that? And this also allowed us to kind of introduce students to some more data science type learning in terms of the kind of core concepts of programming, things like loops and conditional statements, things that are really useful when it comes to recoding data, and are also more generally very transferable in terms of if the student goes on and works in a company that, say, has some kind of coding requirement. And then finally, we had some very nice videos that Adrian put together on how to present your data once you've done it. This is really useful for us because students in the first year, their assessment is a research, like a mini research data project. In the second year, they have something that's slightly larger. And in the third year, they have their dissertation. So getting in early with these little video guides on how to actually present your data, we found very helpful. And actually, we got some really nice graphs in our summative assessment. So that was nice. But basically, we boiled this down into how to use Markdown to kind of simplify the nexus between writing up your project and running the statistics, how to produce clear graphs and tables, right? That horrendous copying and pasting of SPSS stuff we didn't have to do because we kind of worked out how you can generate nice text or LaTeX tables that you can put straight into your Markdown document. And then also how you write about statistical output. How do you actually go from that regression table? We didn't do regression, how you go from that t-test table to like a substantive interpretation about the difference in means between two groups in kind of a political population. So that was really nice. And I think students really appreciated that they had these this YouTube repository of extra videos that they could use when doing their assignments, both during the module and at the end for their summative assessment. So did this work? Well, it's going to be very hard to kind of conclusively answer that question given everything that's gone on in the last 18 months, but we do have some kind of suggestive evidence to suggest that we didn't at least make anything worse, and actually some of these look pretty good for us. So here on this graph, I've just got our student feedback scores from 2019 and 2020 respectively. And what you can see is that on the three measures that I've included here, so satisfaction, challenging, whether the module challenged them to achieve their best work, and also whether it was intellectually stimulating, on each of these measures we improved, and sometimes quite drastically, from kind of in the low 3s up to about 4. And I've also included these two extra points here, which are the kind of departmental means across all modules in the department and at the university level too. So, you know, despite the pandemic, everyone did really good, but we can see that there's actually some quite nice increases for our module specifically. Might look a bit low that we're our intellectual stimulating score was still just under 4, but I think kind of bearing in mind here that this is statistics and students, even the most interested, find statistics in general quite dry. It's quite nice that we're kind of getting pretty good scores there, given the kind of subject matter that we're dealing with. I'm particularly pleased with the satisfaction. I think that looks great and is really encouraging. So that's kind of the student feedback. How about student attainment? Well, again, this is just suggestive evidence. I'm not going to attribute this to mine and Adrian's efforts alone, but there is a slight increase in the average grade between the 2 years, going from an average of 61 to an average of about 63 between the 2 academic years. And actually, there's a nice little increase in the number of or the percentage of students achieving a first as well. We found this year when we were marking the assessments that, in fact, some students just really loved this. They really loved the freedom to kind of go out and run R on the data set that they found themselves, and they got really kind of involved and carried away and did some really cool stats, and they were rewarded for it. So that's great. So we kind of, our main takeaway in terms of attainment was that we did no harm, and we potentially did a little bit of good, particularly for students who kind of were really keen and enjoyed the kind of programming aspect of the course. But we weren't without some problems along the way. So I just highlighted kind of the 3 pertinent ones that me and Adrian have discussed. So inevitably in an online flipped classroom where you're not necessarily physically with the students, then when things go wrong with equipment, it's a little harder to troubleshoot. And in particular, when you use things like R and R Studio, because they're so universal, that also means that they're likely to differ quite a lot as you apply them across different things, because the way that they are compatible with those things is by just kind of like leeching onto the specifics of your system. So we found that dependent on the age of your hardware, that would impact what version of RStudio you could download, and then in turn what version of R you could have, and therefore what R packages were available to you. So for example, we had a very nice package called Jamovi, which kind of presents some very nice graphical output when you're running things like t-tests or chi-squared tests. The problem is it has some kind of relatively strict requirements in terms of packages that weren't available to some students who had older hardware and therefore weren't able to install the later versions of RStudio and therefore R. So we ran into a few problems in terms of hardware, nothing that wasn't fixable, and I'll talk about that in the last slide. One particular thing that's problematic are Chromebooks. Chrome OS is just not as widely supported, and if you need to do something like coding, it's not that great. And students do like Chromebooks because they're small and they're cheap and they're efficient. And we found that it was quite hard to troubleshoot Chromebook issues. The second problem was the silent student, and this unfortunately is just a consequence of online learning, I think, is that if a student doesn't want to participate or can't participate, or for some reason misses these lab sessions online, then it's just much harder to monitor how they're doing. And the danger is that you have a portion of students who you can't help in time for the end of the module. And that was something that we were very mindful throughout the course and tried to kind of check in with students if we thought that they were struggling. But it's nevertheless kind of intrinsic to distance, is that it's just harder to keep on top of that monitoring. And then finally, the last thing we found was that lots of students would come to our office hours and say, I'm really stuck. And then they'd open up their R script and they'd have 200 lines of beautiful code running really advanced things that had like extended what we taught them in the labs. And they were saying, I think I don't get it. And the problem is that we just didn't have the mechanisms to kind of tell them that they were doing really well. In a sense, we found that actually we needed new ways of ensuring that these students were actually kind of getting the confidence that in fact their skills were showing. In a sense, that's just because learning stats is always going to be a bit unnerving when you start. It was unnerving for me, and you just need that kind of positive reinforcement that what you're doing is actually the right thing and it's working. And these students just didn't realize how well they were doing. So this is the kind of last slide and what we're thinking about as we move on to 2021 and 2022. And the core message that I think me and Adrian want to get across in this session is just that these online flipped classrooms work. This isn't some kind of subpar method that we'll just have to do because of the pandemic. This is actually a really productive, really efficacious way of teaching students statistics in a way that's both useful to them and easy for them to understand. It was easier for us to address students when they had problems on a one-to-one basis because we had these breakout groups where we didn't have to disrupt the rest of the lab. And so students felt more comfortable sending us a private message saying, can we just go into that breakout room? So I think we picked up on a lot more kind of small issues that would potentially have held those students back had we been in a normal lab and they wouldn't have wanted to kind of expand on those issues amongst their peers. We also had easier ways of kind of increasing contributions in these labs. You know, students just might not be motivated by statistics, but actually using things like anonymous polls where they could just choose one of 4 answers was a really great way for us to kind of increase participation and also to check on the kind of average understanding of the group. And by shifting all of the kind of core content about how you actually do statistics in R, we were able to spend more time learning about how to interpret and report those statistics in the actual interactive face-to-face time that we had. Now, building on the problems in the last slide, just some kind of residual issues that I think are kind of, some are generic to statistics, but some specifically because of our flipped classrooms. The first is that students still don't get the relevance of this module all the time. You know, why am I learning statistics? I'm not going to be running statistics in my class on democratic theory, for example. I think we just have to work really hard to impress upon them that this is not only going to be useful later on in their undergraduate degrees in terms of the research projects that they might do and the dissertations they might write, but also in terms of this being like a key transferable skill that's only going to be more in demand in the future once they leave university. It's not just kind of me stuck in my office doing my research that uses R, right? It's journalists and lawyers and judges, and we just have to impress that on them, that this really is a crucial skill in the 21st century. How we address this hardware, RStudio package nexus, the fact that these things don't necessarily always knit together, and it's very hard to predict because there's just such a diversity of equipment used by students. That's something that we still need to do more with. What we found was with students where we couldn't fix the issue within, say, a week, that we were able to kind of negotiate with the university to provide us with just some online versions of RStudio. So the university gave us some server space so that those students could just log into a web address. And at that point, it becomes much easier because it's not reliant on the student system anymore. They just need to have a reasonable internet connection. And for the small number of students for which that was a problem, we were able to fix it using this kind of online service instead. In terms of the process of assessment, I think what we both agree we need more of is more positive feedback much earlier on. That's particularly key when we think about students applying for their second year modules. I think that there were students by the end of the course who really got this and really enjoyed it and wished that they got it 4 weeks earlier when they had to submit their module choices for the next year. So encouraging and giving that positive feedback much earlier on should hopefully boost our numbers for the kind of subsequent quantitative modules in the second and third years of their courses. And perhaps also slightly shorter summative assignments that just kind of checked the kind of key understanding and implementation of statistics in R might have boosted the confidence of students too. There were still some kind of basic computer skill issues that were slightly notable. So I won't dwell on this too long, but file directories was a weird thing to encounter for some students, because using an iPad or using a Mac that has this nice search bar thing where you can just find anything wherever you save it, they were just less fluent with how folders are nested within each other. And when you're doing coding and when you're trying to access data in a certain folder, you need to kind of have a kind of an understanding of where your files are. So that was a slightly weird one, and that's just something to be mindful of. In terms of the actual software used to run the labs themselves, well, we used Blackboard Ultra this year and it was fine. It worked well. But there were a few connectivity issues at times. I think it's just a smaller service, and students seem to prefer more generic platforms like Zoom. So in the future, I think we'll likely just pivot towards Zoom as we're on today. And then finally, a last point here is just on simplifying resources. So this year has been great. We've produced tons of stuff, loads of guides, and students really appreciate it. But I think we now need to make sure that students can find it and consistently find it, both in terms of their own situations and also in terms of future years of this course. So how do we kind of create those kind of wikis and file repositories where they can access these videos that should hopefully help them along. But that's it. So I think at this point we're happy to open it up to Q&A, and I look forward to hearing from some of you.
Thanks, Adrian. Thanks, Thomas. Some really interesting discussion there. My first question is, would you come and teach me stats, please? It made my life so much easier. We've got some questions in the chat box, actually very similar to some of the ideas and kind of questions that I had actually. So we'll kind of work our way through them and then see where we get to. The first question is one that I posed, and it was, obviously you've done a lot of work here, probably in quite a short space of time, I would imagine. Did you have any issues with kind of approvals at kind of a faculty or kind of university level, or were things kind of smoothed and kind of made easier for you considering the situation?
Do you want to go, Tom? Or?
Oh no, I'll let you go. I think this is more your ballpark.
Yeah, no, I mean, to be honest, it was a relatively smooth process in the end. There was sort of departmental guidance in particular in relation to making sure we used certain types of software for running the classes. But beyond that, they were relatively sort of keen to let us just get on and, you know, plan and make sure that we were happy, we were, you know, achieving those sort of outcomes. So generally, I have to admit, it was a much smoother process than I think I was expecting when we started thinking towards this last May.
I think a linked question really from Ian Stafford. Again, like I mentioned earlier about kind of, a lot of work has obviously taken place, but what was the impact on you and your students' workloads in comparison to the pre-flipped classroom version of the module? So I guess impact on workload in terms of while actually on the course, but also I think what's interesting is the impact on you kind of leading up to the course as well, potentially a lot of pressure.
Do you want to go, Tom? Or?
Sure. I mean, I think it was, I think there was certainly more work in the build up to the course. I don't think there's any denying that. It kind of, as we've probably all experienced this year, recording an hour's lecture takes way longer than an hour. And if you want to do these things where we're kind of screen sharing with our studio as well and kind of flitting between things, and it just takes a bit of time, and you have to make sure that your code works exactly as you want it to prior to these things. But I would say that kind of the benefit of having some of these things as kind of flipped is that technically we should be able to use these videos again next year, and then my workload is halved because it's over 2 or maybe even 3 years. So if we can kind of basically pay it forward and extract some more free time in future years, then I think it's probably a positive change in terms of our workload. Would you agree, Adrian?
Yeah, I would. I mean, yeah, absolutely. The startup costs were definitely high. For background, my knowledge of R going into this was definitely more limited than Tom's. Tom was, absolute godsend to have around in terms of getting to learn this. But I mean, it definitely feels worthwhile. Like, despite the high startup costs, this is an approach that really works, and going forward, our lives are going to be a lot easier having got these, resources and a lot of things around the edge. Fair enough, we might update data sets in a few years, things change, new data becomes available that's interesting. But in terms of sort of a lot of the hard work in terms of putting together the videos about how to load our recoding, things like that are very unlikely to change anytime soon. So they will be useful and prepared for a long time to come.
I guess that leads on to another question, which is what impact do you think it will have on the course in the future? I mean, are you planning to keep an online version of the module, have a blended version, go back to kind of more what you did previously? Again, if we assume in the future kind of student kind of contact and ability to be on campus, etc., returns more to normal levels, are you kind of planning on having some kind of hybrid?
So, I mean, certainly I think our experiences this year, we would both be very happy to keep with online in this sense. I think some of the aspects, particularly in relation to having the breakout room and that sort of direct private chat that students could have along the side, was invaluable in terms of dealing with a lot of things that I think students oftentimes in a face-to-face lab just wouldn't be brave enough to put their hand up, or be willing to put themselves in that vulnerable position of saying, I really don't know, in front of their peers. And I think for me there are definitely a lot of benefits. Whether we'll be, I think it's going to be a question for the higher ups as to whether or not we're allowed to continue in this, but I certainly think we would both be really happy to, should the situation allow.
I think that leads quite nicely to a question from Pete Woodcock. He says you make a compelling case for using the flipped classroom for this module. Have you any reflections on using it more widely? And he makes the point about lectures and the social element of them, and if there's an issue with that element kind of being lost if we kind of flip the classroom in this way.
I mean, from my perspective, I think when we think about when we're no longer under restrictions and in-person stuff is becoming the norm again, I think you can divorce the question of whether there's like a social or in-person element from whether or not it's flipped, and it's probably harder in some senses when you have just simply an hour's worth of lecture material. But I see no reason why you couldn't have, say, an hour's lecture on research design more generally that students can watch in their own time, and then come to the lecture, and that hour's lecture is more of a discussion, right? It's like a wider seminar, or you have a kind of a series of kind of broader discursive points that you want to make and facilitate kind of direct discussion with the students, like a Michael Sandel type lecture, as opposed to kind of, I'm just going to sit here and do my spiel for an hour. So yeah, I think it could work for lots of different things.
That'll certainly be interesting to see how, not just with stats teaching, but kind of teaching more generally, kind of what happens in the 21-22 academic year, but also kind of in the future as well. I think it'll be really interesting as someone who works at an online university to kind of see which elements are retained at institutions and which ones are not. But I think that's probably all we've got time for in terms of questions. So thank you all for coming, and thank you to Adrian and Thomas for such a great session. We'll actually have another session on quants later on this series, and we do hope to do kind of more on this kind of work stream in the Teaching and Learning Network in the future as well. So do watch this space. The session has been recorded and will appear on our website shortly, so please keep an eye out for that as well. And do spread the word about the future webinars. The next webinar is next week on Tuesday, the 15th of June, hosted by Jonathan Floyd from Bristol, on getting political philosophy students to argue for themselves. And Jonathan is actually one of the PSA's Teaching Award winners this year, so it'd be great to hear from him. And if you're not already a PSA member, but want to find out about our member benefits, please go to psa.ac.uk, becoming a member. So thanks again to Adrian and Thomas, and thanks to everybody else for coming.